Welcome to this episode of Michelle's Opinions. The moon is in our atmosphere? Wow. I am using the reader for the news articles I have found on this topic. I hope that doesn't bother you too much, but I really wanted to share this information with you guys because it's really interesting and the effects that it's having. This all could have something to do with another. So enjoy it and remember to do your own research, take what resonates, and leave the rest.
The moon affects the weather in several indirect ways. The moon has a large effect on ocean tides, and tides have a significant effect on the weather in the sense that a world without a moon would experience little or no tides and would have a different system of weather. The moon also has a small effect on polar temperatures. Tidal effect. Since the moon's gravitational force depends on distance, at any given time, the portion of the Earth closest to the moon, i.e., directly underneath it, is most strongly influenced by gravity. This means that when the moon is over an ocean, the water is pulled toward it, creating what is called the tidal bulge. As the moon orbits the Earth, the tidal bulge acts like a wave sweeping around the Earth. This effect causes the tides. Ocean tides. Holy Island tides image by Louise McGilvray from Photolia.com. Generally, 2 low tides and 2 high tides occur in every 24-hour period, about 50 minutes later each day. During the new moon and full moon, high tides are higher and low tides lower than normal. During the first and last quarter moon, high and low tides are more moderate than normal. Tides affect the movement of ocean currents, which affect the weather through the amount of warming or cooling water moving through a given area. For example, water temperature combines with wind strength and direction to define the duration and strength of weather events like the El Niño. Sciencing Video Vault. Midnight. 1:12. Atmospheric tides. The atmosphere is subject to the same tidal forces as the oceans, although to a much lesser extent. Gases are less responsive to tidal forces because they are so much less dense than water. These tides affect atmospheric pressure, a well-known factor in weather systems. However, the increase in atmospheric pressure which can be detected at the front edge of the tidal wave is so small it is thought to be overwhelmed by other factors. Tidal effect on land. Tidal forces also affect solid land, although to much lesser extent than they affect water. New satellites which can measure the Earth's topology confirm that the moon affects the height of the land. Land tides are limited to approximately 1 centimeter, compared with about 1 meter for ocean tides. Some scientists hypothesize that these tiny shifts might affect volcanic activity and earthquakes. Polar temperature. Satellite measurements of the temperature of the atmosphere shows that the poles are 0.55 degrees Celsius, 0.99 degrees Fahrenheit, warmer during a full moon than during a new moon. Measurements show no effect on temperatures in the tropics, but the temperature around the globe is on average 0.02 degrees Celsius, 0.036 degrees Fahrenheit, higher during the full moon. These small temperature changes have a slight but measurable effect on the weather. The gaseous layer that wraps around Earth reaches up to 630,000 kilometers away, or 50 times the diameter of our planet, according to a new study based on observations by the ESA/NASA's Solar and Heliospheric Observatory, SOHO, and published in AGU's Journal of Geophysical Research, Space Physics. The moon flies through Earth's atmosphere, says Igor Balyukhin of Russia's Space Research Institute, lead author of the paper presenting the results. We were not aware of it until we dusted off observations made over 2 decades ago by the SOHO spacecraft. Where our atmosphere merges into outer space, there is a cloud of hydrogen atoms called the geocorona. One of the spacecraft instruments, SWAN, used its sensitive sensors to trace the hydrogen signature and precisely detect how far the very outskirts of the geocorona are. These observations could be done only at certain times of the year, when the Earth and its geocorona came into view for SWAN. For planets with hydrogen in their exospheres, water vapor is often seen closer to their surface. That is the case for Earth, Mars, and Venus. This is especially interesting when looking for planets with potential reservoirs of water beyond our solar system, explains Jean-Louis Berthez, co-author and former principal investigator of SWAN. The first telescope on the Moon, placed by Apollo 16 astronauts in 1972, captured an evocative image of the geocorona surrounding Earth and glowing brightly in ultraviolet light. At that time, the astronauts on the lunar surface did not know that they were actually embedded in the outskirts of the geocorona, says Jean-Louis. Earth's geocorona from the Moon. The Earth and its hydrogen envelope, or geocorona, as seen from the Moon. This ultraviolet picture was taken in 1972 with a camera operated by Apollo 16 astronauts on the Moon. Credit, NASA. Cloud of hydrogen. The Sun interacts with hydrogen atoms through a particular wavelength of ultraviolet light called Lyman alpha, which the atoms can both absorb and emit. Since this type of light is absorbed by Earth's atmosphere, it can only be observed from space. Thanks to its hydrogen absorption cell, the SWAN instrument could selectively measure the Lyman alpha light from the geocorona and discard hydrogen atoms further out in interplanetary space. The new study revealed that sunlight compresses hydrogen atoms in the geocorona on Earth's day side, and also produces a region of enhanced density on the night side. The denser day side region of hydrogen is still rather sparse, with just 70 atoms per cubic centimeter at 60,000 kilometers above Earth's surface, and about 0.2 atoms at the Moon's distance. On Earth we would call it vacuum, so this extra source of hydrogen is not significant enough to facilitate space exploration, says Igor. The good news is that these particles do not pose any threat for space travelers on future crewed missions orbiting the Moon. There is also ultraviolet radiation associated to the geocorona, as the hydrogen atoms scatter sunlight in all directions, but the impact on astronauts in lunar orbit would be negligible compared to the main source of radiation, the Sun, says Jean-Louis Berthez. On the downside, the Earth's geocorona could interfere with future astronomical observations performed in the vicinity of the Moon. SOHO observation of the geocorona. The intensity of hydrogen atom emission in the outermost part of Earth's atmosphere, the geocorona, as measured by the SWAN instrument on board the ESA/NASA's Solar and Heliospheric Observatory, SOHO. Low intensity is indicated in blue, high intensity in red. The data revealed that the geocorona extends well beyond the orbit of the Moon, reaching up to 630,000 kilometers above Earth's surface, or 50 times the diameter of our planet. Earth is located at the center of the white area, too small to be visible at this scale. The extent of the Moon's orbit around Earth is indicated as a dotted ellipse for reference. Credit, ESA/NASA/SOHO/SWAN, I. Bailey-Ucken et al., 2019. Space telescopes observing the sky in ultraviolet wavelengths to study the chemical composition of stars and galaxies would need to take this into account, adds Jean-Louis. The power of archives. Launched in December 1995, the SOHO Space Observatory has been studying the Sun, from its deep core to the outer corona and the solar wind, for over 2 decades. The satellite orbits around the first Lagrange point, L1, some 1.5 million kilometers from Earth towards the Sun. This location is a good vantage point to observe the geocorona from outside. SOHO's SWAN instrument imaged Earth and its extended atmosphere on 3 occasions between 1996 and 1998. Jean-Louis and Igor's research team in Russia decided to retrieve this data set from the archives for further analysis. These unique views of the whole geocorona as seen from SOHO are now shedding new light on Earth's atmosphere. Data archived many years ago can often be exploited for new science, says Bernhard Fleck, ESA SOHO project scientist. This discovery highlights the value of data collected over 20 years ago and the exceptional performance of SOHO. The main way the moon affects the Earth is the tides. The moon plays an important role in protecting the Earth from space rocks, such as meteorites. More subtle effects of the moon include minor effects on climate, the heat of the crust and the speed of the Earth's rotation. The tidal effect of the moon only significantly affects the largest bodies of water, such as the major oceans. The gravity of the moon pulls the water in the oceans toward it. As the Earth rotates, the bulge shifts through the different regions of the globe. Tides appear on both sides of the Earth because of the pull of the sun. The moon is an important buffer between the Earth and extraterrestrial bodies, which was more important during the initial formation when the Earth and moon were closer together. However, the moon is gradually shifting away from the Earth, so its protection is much less than in the past. Minor effects are not very noticeable except when they are on a very large scale. For example, the length of a day on Earth is slightly longer now than it was in the time of the dinosaurs. The tidal forces also affect the crust, which contributes to the heat of the magma underneath. Tidal forces also keep ocean currents moving, which has a small effect on climate due to cool and warm water moving through the oceans.
Moon thought to play major role in maintaining Earth's magnetic field. Centre National de la Recherche Scientifique, CNRS, press release. April 1, 2016. Astronomy Now. The gravitational effects associated with the presence of the Moon and Sun cause cyclical deformation of the Earth's mantle and wobbles in its rotation axis. This mechanical forcing applied to the whole planet causes strong currents in the outer core, which is made up of a liquid iron alloy of very low viscosity. Such currents are enough to generate the Earth's magnetic field. Illustration credit, copyright Julian Monter and Dennis Androilt. The Earth's magnetic field permanently protects us from the charged particles and radiation that originate in the Sun. This shield is produced by the geodynamo, the rapid motion of huge quantities of liquid iron alloy in the Earth's outer core. To maintain this magnetic field until the present day, the classical model required the Earth's core to have cooled by around 3000 degrees C over the past 4.3 billion years. Now, a team of researchers from CNRS and Université Blaise Pascal suggests that, on the contrary, its temperature has fallen by only 300 degrees C. The action of the Moon, overlooked until now, is thought to have compensated for this difference and kept the geodynamo active. Their work was published on 30 March 2016 in the journal Earth and Planetary Science Letters. The classical model of the formation of Earth's magnetic field raised a major paradox. For the geodynamo to work, the Earth would have had to be totally molten 4 billion years ago, and its core would have had to slowly cool from around 6,800 degrees C at that time to 3,800 degrees C today. However, recent modeling of the early evolution of the internal temperature of the planet, together with geochemical studies of the composition of the oldest carbonatites and basalts, do not support such cooling. With such high temperatures being ruled out, the researchers propose another source of energy in their study. The Earth has a slightly flattened shape and rotates about an inclined axis that wobbles around the poles. Its mantle deforms elastically due to tidal effects caused by the Moon. The researchers show that this effect could continuously stimulate the motion of the liquid iron alloy making up the outer core, and in return generate Earth's magnetic field. The Earth continuously receives 3,700 billion watts of power through the transfer of the gravitational and rotational energy of the Earth-Moon-Sun system, and over 1,000 billion watts is thought to be available to bring about this type of motion in the outer core. This energy is enough to generate the Earth's magnetic field, which together with the Moon, resolves the major paradox in the classical theory. The effect of gravitational forces on a planet's magnetic field has already been well documented for two of Jupiter's moons, Io and Europa, and for a number of exoplanets. Since neither the Earth's rotation around its axis, nor the direction of its axis, nor the Moon's orbit are perfectly regular, their combined effect on motion in the core is unstable and can cause fluctuations in the geodynamo.
This process could account for certain heat pulses in the outer core and at its boundary with the Earth's mantle. Over the course of time, this may have led to peaks in deep mantle melting and possibly to major volcanic events at the Earth's surface. This new model shows that the Moon's effect on the Earth goes well beyond merely causing tides. The Moon's ancient atmosphere. For nearly 70 million years, the Moon had an atmosphere formed by volcanic gas. By Jake Parks, published, Friday, October 6, 2017. In this artist's concept, the Imbrium Basin on the Moon erupts with volcanic activity 3.5 billion years ago, releasing thick clouds of gas so rapidly that it formed a temporary lunar atmosphere. NASA/MSFC. The Moon has been through some rough times. Just a few 100 million years after its formation, it experienced what astronomers like to call the period of late heavy bombardment. During this time, lasting from about 4.1 to 3.8 billion years ago, the Moon, and indeed, the entire inner solar system, endured endless artillery strikes from interplanetary debris. On the Moon, this triggered a series of volcanic eruptions that left its surface a hellish landscape filled with lava flows that stretched on for hundreds of miles. In a recent study published in Earth and Planetary Science Letters, a pair of researchers showed that between 3 and 4 billion years ago, when the primordial Moon underwent this extremely violent period of volcanic activity, it spewed out enough gas to produce a relatively thick atmosphere that persisted for about 70 million years. In this artist's concept, the Moon is shown during the period of late heavy bombardment, above, and as it appears today, below. Tim Wetherill, Australian National University. Although this atmosphere was extremely thick by lunar standards, it pales in comparison to that of Earth. At its densest, around 3.5 billion years ago, the Moon's atmosphere would exert a pressure of about 1 kilopascal, whereas at sea level on Earth, we experience around 100 kilopascals of pressure. In order to calculate how much gas was present in the ancient lunar atmosphere, research scientist Deborah H. Needham of NASA Marshall Space Flight Center and senior staff scientist David A. Kring of the Lunar and Planetary Institute, LPI, analyzed ancient lava flows on the Moon's surface called Maria, as well as moon rocks collected during the Apollo 15 and 17 missions. By examining the rocks, the researchers determined what types of gases were present, while mapping the solidified lava flows allowed them to estimate the total volume of gas that was produced. In the Apollo rock samples, the researchers found evidence of carbon monoxide, hydrogen, and oxygen, the ingredients for water, sulfur, and a number of other volatile gases. Furthermore, the researchers used the rocks to calculate when the most intense periods of lunar volcanism occurred about 3.8 and 3.5 billion years ago. This time sequence of the lunar surface shows how lunar seas of basalt, a type of dark, grainy volcanic rock, changed in 500 million year increments. Red areas show new deposits of the volcanic byproduct. Deborah Needham. This work dramatically changes our view of the Moon from an airless rocky body to one that used to be surrounded by an atmosphere more prevalent than that surrounding Mars today, said Kring in a press release. Though the vast majority of the lunar atmosphere escaped the Moon's gravity and drifted off into space, there are some gases that could have settled into freezing, shaded craters near the lunar poles. If so, these volatile gases may be trapped in icy deposits, forming reservoirs of air and fuel that astronauts can tap into for future missions to the Moon and beyond. And in that case, maybe the Moon's rough time was worth it.
I wanted to share this image with you, and this is an image that we were brought up in school learning was the atmosphere that surrounded the Earth. Now, as things evolve and time evolves, we learn more about what's going on around us. Even the things that were put into the past or carved into the stone images show us the importance on what the value was that they put on astronomy. And there must be a reason for this. As we are now told that the Moon is inside of our atmosphere, That could tell us a ton of things about what is going on with the world around us. So, as we're looking at this image here of our atmosphere, you can see that different things can handle different areas of the Earth's atmosphere. Like a plane can fly up and be at a certain, was it 300,000 feet above sea level, but they have to pressurize the cabin and pump the oxygen in for people to be able to breathe and fly through the air comfortably. Just something to think about as we think about walking, or the hikers that can hike to the top of Mount Shasta. Well, by doing that, they need to bring with them oxygen or other means of being able to breathe the atmosphere, and that's here on Earth. Because Mount Shasta is so high above sea level, the same thing goes along with airplanes, as I was just explaining. The higher we get above sea level from our Earth plane, planet, however you look at it, the more pressure that would need to be handled, and also the more oxygen friendly and able for the ability for us to be able to breathe and function naturally. Now, of course, gravity is going to be an issue because the gravitational pull will be different. I like that, a lot of these things are revealed to us, and they're done through comedy. That is the best way to get information out to people so they can understand the cause and effect without scaring people. The moon coming closer to Earth, to the point where they're now saying it's in our atmosphere, could be causing a lot of these very strange weather phenomena. We're not even having a spring. We went straight from winter into summer, where we normally have a nice springtime where we can enjoy between the 70s and 80s for a good 3 months. We went straight from winter, we're cold, into it's so hot that we're in the 85 to 90s overnight. As you can see in the image here with Bruce Almighty, when he pulled the moon in, it did affect what was going on in the sky, as you saw the meteors. Now, we've had volcanic eruptions and all kinds of different things reported to us on the news, along with an uptick in earthquakes and all kinds of different weather phenomena. Now, I say take everything with a grain of salt. But when you have your own family and people that you know and you love and you trust that are actually going through these very things, and it's happening, and they're taking pictures and they're sending it to you as they're living through it, well, to me, that is a source it's a valid source. There is no green screen. They are actually going through it. Now, I'm just sharing information with you, and I hope that you do your own research. Take what resonates with you and leave the rest. But do your own research. Look around at what is going on and come to your own conclusions, because these things are affecting each and every one of us, along with the planet or plane, again, like I said, that we live on. And we're in this together. So, yeah. I hope that this helped you and helps to inspire you to look into it for yourself. And I love I love the todaysies. It even brings that up in this comedy It's great. Let's watch him just pull that moon one more time as he cleans the sky up, and he lassos the moon for the love of his life to impress her with his new godlike abilities, but is not paying attention to the effects that he has by using the very gifts and abilities that he now has, which causes a meteor storm right when they turn around from it. And of course, watch this movie for yourself. There's a lot of things revealed in comedy. I hope you've enjoyed this episode of Michelle's Opinions. The moon is in our atmosphere. Remember always to share what you know so we can all listen and grow. I'll see you guys real soon. Thank you, everybody. I love you so much.